Welcome, everybody. Really happy to have you all here. For those who don't know me, my name is Annie. I am the city manager of Wagon here in Berlin. And first, I'd like to give a massive thank you to our team that made it happen, that we can right now have a demo day during our pandemic, basically. So thanks so much for making it happen that we're all here. So, before we start with our 7 amazing projects, I kind of want to tell you a little bit about Wagon. What is Wagon and what do we do? Oops. So, first, what is a question for all of you? How many of you have been having this issue already? Like, you have an amazing idea, you want to start a startup, but you don't have a clue how to build a startup. Or, second, you're working in a technical team and you don't have a clue what your team is saying and your developers. They're basically speaking in ancient Greek to you and you don't have a clue what they're doing. Or the last one, you want to switch careers. I think we have a full room of people here that want to switch careers or want to deep dive into their skills, but they don't really know where to get these skills. So, long story short, you don't really know what you're doing. That's where we come in. We bring technical skills to creative people like you. We teach you how to code and how you can land your dream job. We teach you how you can build your digital product afterwards. And we also have an amazing way how you can actually reinvent you as a persona and as somebody who really wants to have a new career. We have 2 different ways of doing that at Wagon. One of them is the Web Development Bootcamp. This Web Development Bootcamp is teaching people how they have, within 9 weeks, to create a full-stack app. They're becoming full-stack developers. They're creating a fully functioning and also beautiful application. And we also have the Data Science Bootcamp. That's why we're here today. We teach them how to learn the fundamentals of Python, the data analysis, machine learning, and afterwards a deep dive into the miracle world of basically deep learning. We do this with a bootcamp. This bootcamp is 9 weeks. It's pretty intense. We have 450 hours of coding, but if I look at the people here, I think they've made quite a few more hours. It's an amazing 9 weeks where we touch a lot of different topics. We touch up on Python, we touch up on SQL, databases, deep learning, machine learning, a lot of new skills that you teach. If you don't have the luxury that you can take 9 weeks off from your job or from your studies, we also have the part-time bootcamp. With this part-time bootcamp, you learn basically exactly the same, but over a longer period of 24 weeks. So, I have to say we're actually doing it pretty well. We are the #1 rated bootcamp in the heart of the startup scene here in Europe, basically, in Berlin. And you're all for sure wondering, what do we do? What are the alumni doing afterwards? We have great companies that are hiring the alumni. Think about Moonfair, Contentful, Babbel, Adjust, but also BCG Digital Ventures. We're also very proud of the amount of startups that are actually coming out of our bootcamps. We have over 100 startups. Plus, these 100 startups also raised already 100 million euros as funding for the startups to get really skyrocketing. So, who are these alumni? The first one I want to introduce you to is Karen. Karen came from Spain, moved to Berlin, and started her job as customer service agent. She realized that's not something she wanted to do, did her bootcamp, and now she's working as backend developer at Babbel. We also have Gary. Gary was working as a banker in the US, and he was working with a lot of user-unfriendly apps, and they were actually fairly boring. What he did is he came to Berlin, did our bootcamp, and now he's working as a product manager at Moonfair, one of the hippest fintechs that we have in Berlin. And we also have Quitterie. She did a business school in France, saw a gap in the market, wanted to step in, but she didn't have the coding skills. Came to Wagon, started her own startup Scalo, and raised 8 million. All of these alumni have a lifelong time access to all of the learning materials. So all of the lectures that you've had, all of the cheat sheets that you've had, everything that there is, all the tutorials, you'll always have access to. It gets updated, so whenever you maybe forgot one of the topics that we've taught you, you can always look back. The cool thing is that we have an amazing global network. We have trained over 9,000 people already, and today more than 400 people are graduating all over the world. It's something that you can be really proud of, and this is a network that you definitely should use. We have an amazing community. Here in Berlin, we have over 700 people already, and I would say really enjoy it. I'd like to give the word now to our lead teacher and developer, Suza. She has been chasing her students for 9 weeks, and here you go.
Thank you, Annie. So, I'm not here to say anything. I'm just Zeus. You all know me from all the harassing messages on Slack and asking you for reactions and doing some lectures and stuff. Basically, I just wanted to invite to the first group and start with the presentations right away. So basically, does anyone remember the time when we had the old school cameras? Like when you had a film and when you were making a picture, you were actually taking the time to take a picture because you were only making one? I don't think that many people remember those times. But right now what we have are mobile phones, right? If you take a picture, you don't take one picture, you take 100. You have many screenshots, you have documents and so on. You forget about it, but at some point you have to deal with it. So I think that the project that will come first has a solution for it, and Kaspar and his team will tell you a bit more about that.
Okay, yeah, this is us, Project Apollo. Thank you all for being here, first of all. As Suza already mentioned, we thought there's a big problem with just clustered up storage space. And we thought, why not solve this problem? Just a quick explanation, first of all, about the name, Apollo. He's the Greek god of vision, of sun, and of light, and also of archery. And we thought that's quite fitting because obviously vision, light, sun, that all has to do with photography. And also archery because we thought our model should be as precise as Apollo is with a bow. And that's why we chose him as our little icon for this app. So as Suza already mentioned, there's a problem with taking loads of images with phones, smartphones we all have. And basically what happens is that we just basically cluster up all our storage space with basically useless pictures that we don't really look at again. So that could be duplicates of pictures, screenshots, and of course also when you just take the same picture of the same sunset for like the 100th time because it's so beautiful. But at the end of the day, you're only going to look at that picture for maybe, I don't know, well at least you're only going to look at one of those pictures. And of course, deleting all of these pictures manually is pretty annoying, and at the same time paying for extra cloud storage is quite expensive. So why not just develop an algorithm or a program which solves this problem, detects all of these pictures automatically, and then categorizes them and puts them into separate folders where you can then either delete them or just flick through them and have a look at which of these pictures you really want to keep. And that's exactly what we try to do and what we have done. So the first step of this is to remove duplicates, because these are obviously pictures that you just really don't need. You don't need the exact same pictures twice. So Flo's just, let's go back a sec. Flo's just going to show us how this works. This is the wrong one, I think. This is the right one. So you just put in the file path into this app, and then just press filter out duplicates. And what happens is that a new folder is created. So as you can see, duplicate folder, these are all duplicate images which were in this folder twice. And I'll just briefly explain how this works exactly, if we go to this proper slide. So essentially what our algorithm is doing is every pixel in these pictures is turned into a number, or to be precise, a combination of numbers. And essentially what's happening is that if all of these number combinations are the same, then we know it's a duplicate. And for every unique picture, there's a unique key assigned to the image, and then if you got the same key twice, then you know obviously it has to be a duplicate. The next step is to filter out screenshots and pictures of notes or documents. Flo's just going to run this really quickly to show you how it works. So again, you just press the button and the work's done automatically. So again, you see there are 2 new folders created. These are now categorized as screenshots in this folder, and if you just go on the other one, the notes folder, that's a duplicate one. There we are, and you can see these are all notes. So brilliant, we've now filtered out screenshots and notes as well. Again, I'll just briefly explain how this works in a sort of simplified version. So essentially what we did, we trained a convolutional neural network. What that is, it's an algorithm which essentially works a bit like a human brain, in the sense that you've got neurons, which are in a way tiny little algorithms, and they're all connected in a big network. And what's happening is that they take the quantified picture as input and look for patterns in the numbers. And if there are similar patterns, then the algorithm detects that there are similar features and that the pictures look sort of similar, and that way it can classify them into, well, either one of these three categories we've got. And then having done these two steps, we move on to the third one, which is to flag similar looking pictures so the user can then have a look at them and filter them out. Once again, I'm going to ask Flo to quickly do that. Briefly explain how it works, or we can have a look at the results first as well. Maybe it hasn't finished quite yet. I'll just explain how it works in the meantime. Okay, so, I mean, we all have this problem. We take a picture of the same sunset, or we take a selfie for like 100 times, and obviously we don't need all of these pictures. And this is what this algorithm is for. Basically, how it works is that it categorizes, or it detects 1,000 different features, so 1,000 different patterns, number patterns in the image. And I'll just explain it to you this way. So think about it this way. Imagine it only has 3 features. Then each of these features obviously is given a number, because we're putting a quantified version of the picture in as input. And then it's going to locate this in the 3-dimensional space. So imagine you've got a 3-dimensional space, and each of these dimensions has one number. Then you could sort of localize it in 3-dimensional space. And essentially what's happening, it's the same thing for 1,000 images, 1,000 features. And the closer they are in this space, the more similar they are. And this way we can detect similar pictures. And now it has run. And if you just go on the folder, you can see there are 4 beautiful selfies of myself. And they're all fairly similar. And if you just, if you have a look at the bottom right pictures, there are 2 mountain landscapes. And in fact, what's happening is they're obviously not that similar, but that's not the point. One of the similar pictures is being kept in the original folder, which means that there are basically 2 pictures looking very similar to the 2 mountain pictures in the original data set. And as you can see, if you actually scroll up, oh yeah, there's one. And if you scroll up a bit, the same thing is happening for the selfie. So one is always kept, just in case, because if you delete the whole folder, at least one similar one is kept. And this way we're basically able to filter out duplicates, screenshots, pictures of notes, and also highly similar photos. And at the end of the day, you've got a cleaned up camera roll without all the unnecessary pictures, and you are actually able to find the pictures you want to find when you do want to find them. Thank you. Also, a quick thank you to the team. You've been amazing.
Okay, I will do it. I would like to thank Caspar, Flo, who you have still there. I don't give it to me. Caspar, Flo, Timmy, and Nick, who built this amazing product. And guys, you may think of it like just picture sorting. It is an actual mechanism behind the scenes who's doing the job for you. So there is no human interaction, and it's done all automatically. So great, great, great job. So the next project. Is anyone here using Spotify? Yes. It's the time of the yearly summaries, right? Like Ben has been harassing me about it for the entire week. For me, this was the reminder about how actually I really miss the real stuff, the clubs, the DJs, and there's no chance really to like experience the real music unless you just play the boiler room sets on YouTube. But how often can you do that? And I think that GUI has a solution for that as well. If you wanna come and tell us a little bit about it.
Thank you, Zuza. Hey guys, good evening. Anyone here into music? Okay, good. I'm into music as well. As a music lover, I love Spotify. It has a huge selection of songs. It has endless amount of libraries. It even has a decent recommendation system. But I'm not here to sell you guys Spotify. The company that gave Joe Rogan $100 million just to get off YouTube doesn't need me to do anything for it. What I'm here to tell you is what I'm missing on Spotify. I'm talking about gaining control over my music. So oftentimes, I mean, surely Spotify has endless amount of libraries for every mood that you might have. But basically, at the end of the day, those playlists are just a random collection of songs that are not organized in any way. Another thing is that big players like Spotify suffer from a thing called popularity bias, which basically means that most of the music that you see on Spotify playlists come from a very small source of songs. Okay, but why am I telling you this? Because I'm oftentimes when I listen to music, I find myself going to SoundCloud instead of, if I want to listen to a DJ set, let's say, if I'm sitting around with friends, if I'm working out, if I'm sitting and reminiscing about times we went partying at clubs, I have to go there to SoundCloud or YouTube, Boiler Room, as Uza said. And that's really a shame, because I'd really be happy to have all of my music experience based on one place. And so I decided to step up the game and take the music recommendation game to the next step. And that's why my great team and I have created Pick for you, which helps you gain control over your music libraries and playlists and get that DJ experience that we are all missing during lockdown. Okay, so we built a website just for that. And so if you go to the website and you choose a playlist, let's say today I'm feeling like listening to house music. And I want something fresh. If I'm working out, I want to get nice preferences that are recent. So I'll go from 2020. I'm working out for, let's say, 60 minutes, okay? And I want something popular to get me through my workout. Okay, then I name it Wagon Gi. And after I name it, we click that create button, and the music is being created for us. But what happened behind the scenes? Well, we start with a very large data set with tons of music from Spotify. And every song on that data set has a bunch of characteristics. Now, out of those characteristics, for our purpose of the project, we found that the most important ones are tempo, danceability, and energy. They are the ones that give us the best results. Okay, so from that filtered data set, based on the user preferences, we take one random song. And you can see in the graph, that's the red point over there. And on that filtered data set, we run a KNN model, which stands for K nearest neighbors, which is a machine learning algorithm that what it does is it's looking for the most similar songs to that seed song, to that red dot that you see over there. And and it kind of tells us how distant the other songs is from that seed song. Okay, if you look inside the circle, now we have all of the points that are there could actually create our playlist because they're pretty near one another. But it's still not organized in a way that necessarily makes sense. And so that's why our next step is to sort the playlist. And we sorted it by tempo, starting, slowly increasing the tempo until we reach the peak at the somewhere in the middle of the playlist. And then after that, we start decreasing the tempo again and making, gives us the feeling that you'd get in a club, which again, we're greatly missing during these times. So let's go back to our web page. As you can see, the playlist that is being created is there. And let's give it a shot. See how it sounds like. Okay, we can't hear it, but maybe the people at home can. Okay, so you can see that the first song is kind of slow. It's not really like hard pace, and that's the beginning of the curve. And then if we go to the middle of the playlist, you can see that slowly the tempo is increasing. And then after that, if we go to the last song of the playlist, you can see that it's already kind of like chill and like more calm down. And yeah, that's what we're going here for, actually. So from that webpage, you can listen to the playlist on that webpage. You can also follow it on your personal Spotify account from our Spotify page. And yeah, I encourage you to try it. I mean, yeah, the product that we put is really good. If you're gonna use it, I'm sure that you're not gonna go to SoundCloud or YouTube anymore. You're just gonna enjoy it on Spotify. Thank you. And also, I'd like to say thank you for my lovely team, Luam, Linda, and Michel, for our TAs, especially George, and of course, Zuza and Ben. Thank you.
Thank you. Someone is really missing clubbing. You repeated it so many times. I really feel you. Okay, guys. So clubbing, music, DJs. Let's jump straight into drugs. What I mean is medication. So Henrike, who is an expert here, she's a pharmacist, can explain you a bit more. Okay? Disinfection first. She knows.
So, hello. Yeah, I would also like to start out with a question, and the question is: has any of you ever had a side effect from the medication that you're taking? I mean, yes. Have you checked the leaflet if it's described in there? No. Usually it should be described there. However, in some cases it happens that it's not, because the medication is tested on in clinical trials only, and afterwards over 100,000 people take it, and it's possible that rare side effects occur that hasn't been detected before. There's a whole industry out there for this. This is called pharmacovigilance. And as you can see on the picture here on the right, there's oh no, it's the left. This side. You can see that it relies on different sources, especially literature reports, clinical trials, and also, and that's the biggest part, spontaneous reports. Spontaneous reports come from doctors or pharmacists who detect this and report this to either an agency or the company. However, this has some drawbacks, because most of the time the people don't really have the time to do this, or they say, okay, I have known about this before, so why would I issue a report? But then we don't get an actual picture of the quantity of this side effect happening. And our aim was to get a bigger picture of side effects that occur by using a whole different source. And this would be patient drug reviews that you can find online. There's websites out there that where people can just go online and write what they think about the drug they've been taking. For this, we used a Kaggle data set with over 200,000 drug reviews. And the people did not only describe how they liked the drug, but they could also say what condition they have been taking it for, and they could rate it from 1 to 10 according to their liking. We have here a picture of the most frequent words in those reviews, and as you can see, side effect is the most common thing that people talk about when they talk about their drugs online. When working with this data, we came across a few problems. The first one was that the data set is not labeled. With labeled, I mean that we don't know if the review is actually talking about a side effect or just about something completely else. And if you look how the word side effect is used in those reviews, it is used in different contexts. For this first review, for example, people were describing the actual side effects. Then we have another review where a person described that she didn't have a side effect. And then yet another review where the person said that she had side effects on other drugs, but not on this one. So just looking for drug side effects in the reviews is not enough. The second problem was that people don't talk in medical terms. So this person here is describing how she felt during a panic attack. There is a doctor which is described as a diagnosis, which is anxiety disorder. And we have another example here where a person describes how the lips changed under acne medication. And there's also a medical term for there, which you probably have never heard of before. But this is how you would code this when you do an official side effect register. And Peter is now going to tell you how we worked with those problems and what solution we found for this.
Got one. So far tonight, you've seen and heard of a lot of really complicated, interesting, and powerful machine learning tools. That is not where we started. We started with a very dumb tool. So as Hendrike mentioned, all of these reviews had ratings attached to them, how well people liked the drugs that they were reviewing. And we kind of had the idea that, if they rated it lowly, there's probably some pretty bad side effects there. So what we did was Hendrike, our resident pharmacy expert, manually labeled 300 reviews on whether or not they had a side effect. Then we took a look at them, comparing their ratings, and yes, indeed, if you look at anything with a 5 or lower, there's a really good chance there's a side effect there. So the first thing we did was simply get rid of anything rated highly. That helped sort our data really nicely. But then we did start getting into some more complicated models, including BERT word embeddings. BERT is just another tool, like some of the ones you've been exposed to so far. That is, you can think of it as a really fancy thesaurus. So we put in a list of words that we found correlated with positive reviews, things that didn't have side effects, and a short list of words that related to some common side effects. We threw them into BERT and had it compare it to a gigaword of 6 billion tokens, so 6 billion words, and it spit back out for us a set of words to look for similar to the words describing side effects and similar to the words that were describing no side effects. As you can see from that, the positive ones, things to look for in good reviews were things like improvement, improve, better, good, change, and things not so good, numbness, sweating, itching. Yeah. Additionally, there's that issue of how people talk. If you go to a vending machine, how many of you get a soda? How many of you would say you would get a cola, or a Coke, or a pop? They're all the same darn thing, but we all use different words for it. My dad uses Coke for literally anything that is sugary and carbonated. He could come back with a root beer, you never know. So we used another tool as well called Word2Vec. It's very, very similar to BERT, but instead of pulling from this other separate data source of 6 billion words, what this did is called a skipgram. So it kind of looked through the reviews and looked for words that showed up close to each other within the sentences and used that to help figure out, oh, these two words are pretty similar to each other. They tend to show up a lot together. Graphed on a 3D model here, again, the things that are close together have meanings that are close together. The actual numbers, the vectors, don't have a lot of meaning. We're just looking for how close they are. So the one in the middle there, dizziness, the things close to it, things like fuzzy, things like insomnia, nausea, those are all close to it, so we can expect that this person's probably describing more or less the same thing as the other guy if they're using similar words. So with all of this, we created a website that you can go to and search through the results that we came up with after sorting through all of this data. So if you would please, Jack. In this particular website, as you can see here, nice, it will give you a couple different pieces of information. As you search for it, like Abilify, for example, and request it, beautiful, it will give you the list of drug side effect categories that we came up with and the percentage of the reviews that mention it. So for this one, Abilify, 8% of the reviews mention some sort of depressive side effects, whether that be sadness, feeling low, insomnia, things that tend to be associated with depression. And discomfort was really high, 12%. So if you're on this drug, there's a 1 in 10 chance that you're going to be feeling some discomfort. discomfort. You can do this with any drug that is in our database. It's a little bit over 2,000 drugs that were included within that. All of them have some data associated with them. Some of them, happily, have no side effects. Yay! Those also happen to have 3 reviews, so yeah, take from that what you will. To get some more information about our data, you can go to the About page on this, where there is a link to the data source so you can see the reviews for yourself. There's a list of our side effects categories, so you can see exactly the words that we've been searching for each of them. So for example, that depression we mentioned before, mood swings, moody, weepy, things like that were the exact words that we're looking for. And of course, because we're dealing with medicine, there's a disclaimer. This tool does not provide medical advice. It is the result of 4 students playing with a dataset and intended for informational purposes only. Do not use it as a substitute for professional medical advice, diagnosis, or treatment. You understand and acknowledge that you should always ask the advice of your physician or other qualified health provider with any questions or concerns you may have regarding your medication. So, thank you. I do hire out for medical commercials as well. So that is our presentation. Feel free to play with this website as you wish as well. It's at sideeffects.herokuapp.com. Before we leave, I would like to, of course, give a huge thank you to the rest of my team. Henrique, who started us off and was our resident expert in this field. Jack and Juan have done amazing work on the back end, dealing with this data, sorting through everything, and going through every language processing tool you can possibly think of to see what was the best for us. Tim, our ever-patient TA that helped us through this process, the rest of the TA team, and of course, Ben and Souza. Thank you all very much.
Thank you so much, guys. So yeah, Peter, you can look for a job as a data scientist, but also something in medical commercials for sure. So we've talked about music, drugs, pictures. Let's talk about money. Everyone is actually using the digital transactions more and more often, right? Like especially in Berlin, which is not a cash-loving place, which everyone learned, I think. And when we use more of the digital transactions, it's like the risk of some fishy business going on behind the scenes is much higher. For example, one of our TAs, Killian, woke up one day, that's a real story. He woke up one day and got a notification on his phone that he just took out 5 million Indonesian rupiahs or something like that. So ideally, you would like to avoid those situations. And Maria can tell us a bit more about it with her team.
Good night, everyone. So our team presented now for you project fraudulent transaction detection, and in a while we will show you what we've been doing all these 2 weeks basically. So it's not a secret for everyone how 2020 basically changed our lives. We started to work from home, study from home, watch Netflix more, eat more, and what is more important, we start to pay online more. Of course, it's very cool when we are sitting on our sofas and like paying for something is very quick, easy, and so on and so forth. But there is one issue, fraud. Basically, when you're going on a website, your personal details can be stolen and used by someone, we don't know who. Killian maybe can tell us about that more. Yeah, so it can be stolen and all your money can be used for you. And basically why it is so bad and why it concerns everyone. Because cost of fraudulent transaction in 2020 was $32 billion, and it's a lot. And it's predicted that fraud transaction cost will increase. And that's why the main question for our team was how we can define whether a transaction is fraudulent or not. Our solution was to build a prediction model, so it will predict whether transaction is fraudulent or not, and to put it on hold, for example, if transaction is fraudulent. And we use a data set from Kaggle, provided by Vesta, e-commerce company, and in more details, now my colleague will tell you more, Antonia.
Thank you. Okay, so at first we got this really big data set, which consisted of over 1 million transactions and something like 400 different columns. So what we did first is do some data pre-processing, meaning we cleaned the data set in order to be able to work with it. And then we also did some feature engineering. So this means from the features that were already in the data set, we created new features which were interesting for us. So for example, what we wanted to know is whether there's specific days of the week where actually more fraudulent transactions happen during the other days. Also what we wanted to know is whether there's specific times throughout the day where most fraud happens. And lastly, we were also able to extract the individual credit cards from the data set and then have a look at credit card specific information. And here's what we found out actually. So first of all, when we had a look at the hour of the day, what you can see in this graph is this grayish part here is all transactions happening throughout the day. So obviously, like at night, there's not a lot of transaction happening, whereas throughout the days, most transactions are taking place. But this graph here really represents the fraction of fraudulent transactions. So this was something quite interesting for us because mostly it happens at night. And now that we have this additional information, we were able to also feed it into our model and then make it predict even better. And next, what we found out, which was interesting, when we had a look at the credit card specific information, what we did is for each credit card, we calculated the average, like from all transactions that were performed on that credit card, we calculated the average transaction amount. And then for each transaction, we calculated the distance from that average. And because we were wondering if there's something special going on, and actually that was also the case, because what you can see here is, again, the green area is the normal transactions, and the red area, this is the fraud. And what we found is that the pattern looks quite similar. However, if you look at this part here, which is transactions that are really far from the average transaction amount, there seems to be a slight increase in fraud. So yeah, that's quite interesting. And now that you know about our features, G is going to talk more about our model.
So in order to analyze which model would suit the best our classification problem, we looked at different metrics. So first of all, we looked at recall, which evaluates the model's ability to detect fraudulent transactions. Second of all, we also looked at the metrics precision, which evaluates the model's ability to avoid false fraudulent transactions. And yeah, finally, what we mainly looked at was the F1 score, which is kind of a combination of both. What we actually found, we used three different kind of models, or we compared three different kind of models. So first of all, we looked at the random forest classifier, the XGBoost classifier, and the LGBM classifier. And what we mainly found is that the random forest classifier gives us both in terms of F1 score and recall the highest score. And that's also why we chose in the end the random forest classifier as our model for this classification problem. What this model mainly does is that these independent models gives an output, and what the random forest mainly does is that it chooses the majority vote, and that's what makes this model best than the other twos. And now Maria is going to present you quickly our web page.
Yeah, so basically the final step of our project was to make an app. And the idea of our app is very easy. A company is coming to us and uploading CSV file. And CSV file with its transaction. And now magic happens. Our model is looking into the data and choosing whether transaction is fraudulent or not. And here we go. And transactions are fraudulent. So basically, what the company now see and what it can do, it's put a transaction on hold and to work with them manually. So basically, that's how it's working for us. And of course, we have a nice graph representing amount of all transaction and fraud transaction. Yeah, that's all. Thank you, everyone, for looking at us today. And yeah, and of course, I want to say very big thank you for TA, I guess, because I told many times how grateful to work with my team. But yeah, big thank you for TA and all those long calls with us, because it was It was really long calls. Thank you.
Thank you so much. So now you know how to keep your money safe. When we talk about money, if it's now secure, the good thing is to actually think how to invest it, maybe, how to spend it now, how to spend it in the future. And actually this group that will be presenting right now took up a task, which is one of the most difficult, challenging topics throughout the entire bootcamp, which is time series. And maybe, Ismail, Guli, could you explain to us why do you have December 5th as the date? Because I don't know, really. It's 4th, Ismail.
Hi, everyone. This is Ishmael coming from the future to present you the Electra project. So why is it the 5th of December? Actually, we were focusing on the day-ahead electricity market, which is actually a wholesale market for electricity, where buyers and sellers from all Europe come to buy and sell electricity for the next day. Some of us people don't have electricity problems, as you can see from the video. Well, no, actually all of us have problems for electricity, and electricity is a very tricky source of energy, and it's also one of the main challenges that our generation is facing. Why? Because demand of electricity is very irregular and unpredictable. Imagine, for example, tonight in Berlin, the temperature is -10. You will all turn the heater on, and this will basically make the demand in electricity surge. The storage of electricity is also very problematic because it's not something that you can actually store at large scale, and there are some constraints in terms of the grid network that doesn't allow electricity to flow wherever you want to send it. So these factors make supply and demand electricity very tricky because you always need to be balancing the supply and demand. They always need to be equal in order to avoid incidents such as blackouts or frequency drops. We were talking about the future. By 2050, which is in less than 30 years, the European Union, within the framework of the Green Deal, wants Europe to be carbon neutral. There's also the new usages such as electric cars, 5G, Internet of Things, that are going to make the price of electricity more volatile in the short term and also in the long run. Renewables are also part of the volatility problem because the more renewables you had in the energy mix, the more the demand is also going to be unpredictable because you cannot control the sun, you cannot control the wind, so it becomes very difficult to also predict the demand. And of course, COVID, which is the best thing that happened to us in 2020, also has completely changed the patterns in terms of human activity, in terms of consumption. People are staying at home, so this completely changes the whole picture. So how is the price determined on the day-ahead market? Basically, you see here, every type of producer of energy will submit the energy generation amount for every hour in the day. You will actually accumulate all of the production, and when the production actually meets the consumption for this hour, the maximum price, the most expensive that matches supply and demand, is actually going to be the price for everyone. And so all the producers are going to be paid this price. Why did we choose Denmark? Denmark is actually a small country in Northern Europe that is surrounded by very big countries. You can see here in the graph that Denmark is on the top. It's very small in terms of energy production, but it is surrounded by very big neighbors. And you can see in green that most of these neighbors are very high renewable as part of their energy production. And Denmark is also a net importer. So if, for example, there's a big surge in production in Germany, this will also have an influence on the price of electricity in Denmark. So the reason why we chose Denmark is because it's one of the most difficult markets where to predict electricity prices. And we chose DK1, which is actually West Denmark. So I'm handing over to Guli.
Thank you for the smile. And so here comes the solution. For the solution, can I try that? Hello. Yeah. So for this, we have a solution which will be coming up with a model can predict the electricity prices with the lowest forecasting rate as possible. That means we need to use a time series model. For that, we selected the SARIMA model first, and then so SARIMA model learns electricity prices from the past and forecast for the future. And as you can see in this plot, the black lines are the past electricity prices, and the orange ones are the electricity prices that we are forecasting. And then we are 95% confident that the electricity prices will be in this gray area. And this black dashed line are the actual electricity prices. So by comparing these two, we calculate the forecasting error rate, which is around 11.5%, but we are not satisfied with this yet. So what we do? What we did is like we spent 3 days, explored all these features, and collected all the data from ENSO and open weather. Like we went to a lot of places, collected this. Collected all these features, which is wind speed. We found wind speed, temperature, humidity, and then holidays and whether the holidays are weekend, kind of improved the accuracy of our model. So let's try that. So by adding these extra features, here our model is SARIMA, X representing all these extra features. And you can see that our forecasting is getting closer to the real actual price. So, and also you can see that our error rate reduced 2.5%. So, but we want to look at for longer time period. So here we are forecasting for 8 months. And as you can see that our forecast, the orange lines are actually capturing most of the real actual prices, except for these negative spikes. And I will explain to you where these negative spikes come from soon. But now let's just try to remove these outliers and see what happens to the error rate. Now we have error rate around 9.9%. And then now I can explain to you where this negative spikes coming from. As Ismail mentioned before, Denmark is surrounded by Germany, close to the Germany, and the German market, electricity price market is huge, and it has this, when the electricity prices in German market drops, it actually has a really big influence on the Denmark electricity market. So to capture all those negative spikes, we actually need to include an additional feature like German weather, which we don't have it yet. But we are planning to work on this in the future. And now we want to see how our model performs comparing to those existing models or professionals. So for this, we selected this paper where the professionals selected several different models and compared their performance on electricity forecasting. And their best performed model has error rate around 11.3%. And our SARIMA had 1.35% less error rate. So we actually, we are very excited about this, but I also want to mention one thing here. So nowadays, there's like, since the neural network came out, people start to develop new models, hybridize new models, which can actually reduce the error rate till 3 to 4%. That's our next aim. And so far I'm only talking about 2019, but I didn't forecast for anything for 2020. Why? As everyone is talking about COVID, of course it's COVID. So because of COVID, most people work from home, and then their demand for the electricity is changing. And also the factories are closing down because of the COVID, and then of course the electricity demand will reduce again. Then government come out with a new policy, like you can go out now, and then restaurants are opening, more electricity are demanded, and then this causes the electricity prices fluctuating a lot. And so it's very challenging year for the forecasting. So this will be our next challenge also. And now I will give the stage to the Ismail.
Hi guys. Sorry. Ishmael again, back from the future. So now let's imagine. Okay, so this is our product. This is the solution we designed for our customer that is called Le Wagon Energy. So imagine you are working for Le Wagon Energy. Basically, Le Wagon Energy has a capacity of 100 megawatt, which is actually more or less 3% of the total electricity generation in Denmark. So it's a medium-sized electricity production company. So with our model and the increase in rate of 1.35%, we are able to actually reduce the error rate and make Le Wagon better produce the electricity prices, and this actually results in 405,000 euros of savings with just the average price that is 36 euros. So now we were saying you are Mr. Le Wagon, you work for Le Wagon Energy, it's Monday morning, you arrived in the office, you drink your coffee. What do? You go to look at the prices of electricity for the next day. So you arrive here on your page of Le Wagon Energy, where you're actually looking at the prices for the DK1. It's West Denmark, as we said before. So you can see here the chart of electricity prices for the day after tomorrow, because today you bought the electricity for tomorrow. Down here, you have also the table with all the prices. You also have this chart that represents the prices of electricity for tomorrow in black that you have already purchased today. And then we have our forecast of the electricity prices for tomorrow. Once you see those prices, you can download the CSV file down here with all the prices, and then you can be in touch with your production or finance department in order to make your bidding strategy for buying electricity in the future. Thank you. Before I forget, special thanks to Tim. He's been very patient and very helpful with us. So Tim, thanks very much. Without him, we wouldn't have been able to produce this in 2 weeks. Special thanks to Grisildo, that is too shy, so you can't see him. He didn't want to come in front of the camera. Chike here did an amazing job. Guli, that you also saw, and myself. Guys, thank you. I think we did an amazing job. So, and let's take it to the next step and then create our energy company.
Microphone coming back from the future. Okay, thank you so much. Thank you also for saving us so much money. Le Wagon Energy is really, really grateful for your help. Moreover, guys, this result is really amazing because they've been working for just, let's be honest, 8 days on a project, and they exceeded the results of actual experts which work on this topic for months. So this is something really, really impressive. Another project, though. Many of you will be looking for jobs soon, and probably you know very well Glassdoor, where you can see the reviews of different employees of different companies, but you know it more from the employee perspective. But now let's think as an actual employer. Usually, they get the reviews on Glassdoor when someone left the company and now can say whatever he or she wants, complain, be happy, and so on. Unfortunately, for the companies, it's a bit too late to react to this. So that's why Teresa and her team created a great product for the managers to actually be closer to their employees in terms of how they feel in the company.
Hello everyone, we're very happy to be able to finally present our product to you. It's about workforce sentiment, and it's actually based on a growing field of research that places heavy emphasis on the relationship between employee happiness and overall business success. So we want to build on that and boost business success through monitoring employee happiness. And also nowadays, it's still quite difficult to measure actual sentiment of your workforce. And if you're using, for example, surveys and analyze them by hand, it can be very inconvenient, and there can also be a lot of bias involved. So we want to solve this problem, and our approach is to analyze employee company reviews and extract overall happiness in relation to different categories, for example, work-life balance or senior management, and also extract the most relevant topics for each of those categories. And we want to display all of that on a dashboard for managers to be able to access it quickly and interpret it easily, so that the managers can actually tackle the problems right where they are. So our solution is a visualization dashboard that on the one hand shows this happiness in different topics, and on the other hand takes out the most important topics relating to each of those categories. So let's have a look and jump right into it. First of all, on the left you see all of the categories that we are going to predict the happiness about. And to show you our app, we actually want to use a little possible use case. So let's all imagine I'm the manager at Amazon, and I sent out a couple of employee surveys about the satisfaction, and I received back answers in the form of text. So I put everything into a CSV file and can upload it here on this website or on this app. Let's do this real quick. And the first thing that I will want to know is how the overall happiness is of those people. So for this, we can have a look at the first pie chart. We can see almost or a bit more than half of the people are quite happy, but there's also quite a bit red part. So we want to know which categories make the employees unhappy. So let's look at the next chart. We're going to use the negative part in here, and this shows us how many percent of all of the negative reviews are represented by each of the categories. In this case, if we look at work-life balance, it's roughly 20% of all negative reviews are related to work-life balance. And this is why we want to take a deeper look into it and see what employees are actually worried about or angry about. For this, let's select the work-life balance on the right and look into the topics. Here we can see another pie chart with the overall happiness. And down there, we are going to take a look at the most representative topics. So the numbers are just random numbers assigned to the different topics, so they don't mean anything. And in this case, we're going to choose topic 4. And here as a manager, I can already see people are obviously quite unimpressed with the long work hours. So I'm able to actually tackle this problem specifically and keep the workforce, hopefully. And how we achieved all of this is back in the slides. So our approach was we had a data set from Kaggle containing 50,000 employee reviews about their companies. And in each of the categories that we had in the app, they had a rating from 1 to 5, and also for the overall happiness. And the models we used were the multinomial naive Bayes and SGD, as well as natural language processing and LDA. And for those of you who are interested in what happened behind the curtains, the next slide is for you. So we actually first fed all of the data into the multinomial naive Bayes. It's just a good way to classify when the input is actually text. And it outputted a couple of arrays with zeros and ones. So we used those arrays and fed this to the stochastic gradient descent, which is another classifier. It's similar to a logistic regression, but it takes as an input not the text, but the arrays that we received from the first model. And the output are ones and zeros, so ones for the reviews that are connotated positively and a 0 for the reviews that are connotated negatively. And on the basis of that, we could divide the reviews in each category into positives and negatives. And this is where the natural language processing came in. So NLP is basically a way for computers to understand our language and actually make sense of it. And a technology of NLP is the LDA, which groups words into meaningful topics, which then hopefully actually make sense. And on the base of that, we were able to create our visualizations, which we're very happy about. And first of all, I would like to thank the whole amazing team, Alvaro and Jungshi, the brains behind everything code, Celine, who brought the project to life actually in the app, and to all our teachers and TAs. We had a lot of fun. Thank you.
And last but not least, I want to thank Teresa, of course, for your contribution to our project and presenting it today. So thanks.
Thank you so much. I love how sleek the app is. It's like any manager can easily use it without even realizing what crazy magic stuff is going out behind the scenes. Last but not least, here's the question. Who reads news here? Yeah? Do you read news? Yeah? Okay, but do you really read them? Because like in my case, to be honest, I read the news, so I scroll and I see the titles and I think that I know what they are talking about. And actually in these times with COVID, with global pandemic, with the economic crisis, there's lots of news coming from all the sites and it's really hard to keep up with them. But Anton, you have something for us that will make it much easier to actually stay up to date when it comes to the news.
Thank you. Good evening, everyone. We are Newsmakers, and Newsmakers is the project we've been working on for the 2 last weeks and which we're very excited to present to you tonight. And so Newsmakers was built around the idea or observation that many people today do not have an optimal experience when reading news online. For many people, when reading news online, it basically sums up to being somewhere on the internet, often on social media, scrolling down a news feed and coming across some news posts. And then people often read the headline, maybe have a quick look at the picture, and if they're curious, they look at 1 or 2 featured comments under the post. And those features and those comments are the featured comments, which are not necessarily the most insightful ones, nor the most representative ones. So, and after having read those comments, many people don't bother actually clicking on the article because they're too lazy to do so, or they don't have access to the article, and they just move on. So they don't know much more than the title and the picture and a useless comment. And so Newsmakers aims to help those people. We built Newsmakers by leveraging data science in order to help those people understand what's actually hidden behind the article. And we did that by creating 2 powerful algorithms. One text summarization algorithm, which takes the entire article and sums it up in a few bullet points, and a sentiment analysis, which goes through each and every comment related to that article, determines whether its sentiment is positive or negative, and then gives you a summary of the overall opinion of that article. So how does it work in practice? In practice, you would just go on your newspaper, the New York Times website, for example. You want to know more about this article about the new coronavirus vaccine. You copy-paste the link on the Newsmakers platform in the input bar. You click submit, and now the magic is happening. Our platform is connected to the New York Times. To the New York Times website, is fetching the content of the article and of the comments and is feeding it to our models, which are crunching the data. And here's the output. Just like on social media, you have the title and the image, but now you also have this nice summary on the side, which is an extractive summary, meaning it extracted the 5 or 4, in this case, 4 most important sentences of the article and presents it in a nice and concise bullet-pointed summary. If you scroll down, you will find the sentiment analysis. As I said before, here you have the breakdown of positive and negative comments. And in order to give you an idea of the most opinionated comments, we extracted the most positive one and the most negative one. In this case, for example, the most positive one is "Good luck to Great Britain, God save the Queen, and God bless the United States of America." And on this positive note, I'll hand over to Yannick.
Thank you, Anton. So let's take a look at what is happening behind the curtain. What is happening behind our website? What you just saw was an extractive summary, meaning that our algorithm looks for characteristic words in an article, and for every sentence, it ranks every sentence in that article dependent on the occurrence of these characteristic words in that sentence. And this algorithm is called term frequency inverse document frequency algorithm. But we also developed another algorithm or another model, which is more complex. It's a neural network, a sequence-to-sequence neural network with an encoder and a decoder. And we were able to feed this neural network with 10,000 articles and handwritten summaries. And now the encoder is capable of more or less get the context of a news article, and the decoder can then generate a summary out of that information. So, but because we just fed it with 10,000 articles and summaries, the summaries are oftentimes not that grammatically correct. So here we choose to show you the extractive model.
Okay, thank you, Yannick. Now coming to our sentiment analysis. So a sentiment analysis is the process of interpreting and classifying emotions in a piece of writing through a natural language processing, machine learning, and deep learning. So in our case, as Anton mentioned, our goal was to go through the comments, or have our model go through the comments and determine whether that comment is positive or negative. So our first step in that case was to first find a good training data set for our models to train on. We used a training data set from the New York Times comments. However, the problem was that this training data set was not labeled, so it didn't say whether that comment was positive or negative. So we used 3 different techniques to label the data, and then basically just filter out those rows where the labels didn't match with one another. Next, we determined a baseline machine learning model, which was a naive-based classifier, which a couple of groups have talked about before already. And we reached an accuracy, which is basically just the rate of correct predictions of 72.8%. So once having this baseline score, our goal was to get better and to outperform ourselves by using a deep learning model. Here we went into two different directions. We checked out recurrent neural networks and convolutional neural networks. So recurrent neural networks basically are a class of neural networks that allow the output to be fed back into as an input, so it basically feeds into itself, while convolutional neural networks use weights and biases to classify and recognize data. So our final model was a convolutional neural network, which also had an embedding layer, and it reached a final accuracy of 92.7%, 20% better than our baseline score, which I personally think is a pretty solid score.
So, although the results are pretty solid, we can't hide the fact that there are some limits to our models. Let's start with the text summarization. The abstractive, or right at this moment, we are training our abstractive model on Google Cloud Platform with 1 million summaries and articles to make it even better. And so if we had more time here, we might have been, or we could have worked out with that model. And to the sentiment analysis, it also would have been nice to train an unsupervised neural network to get the underlying topics in the discussion and also display them. So with 2 more weeks, we could have made better results, even better results, but still I think the results are pretty decent. So we would like to thank all the teachers, especially thank Jesse that he allowed us to train our models on his supercomputer. And yeah, thanks to the whole Le Wagon team for this awesome experience. And thanks to our team. Thank you.
Okay, thank you so much. Really, really impressive with the score, with the app, how it looked, with the front end. You did a really great job. And we can actually stay with this slide because I just wanted to thank you all for being here with us for the 9 weeks. For those who are watching, I just wanted to tell you that these guys started 9 weeks ago not really knowing what data science really is about. And when we were doing rehearsals over the last 3 days, we had to just cut them short a little bit because their explanations were so complex and so advanced and had so much advanced vocabulary that normal people wouldn't be able to understand it. And what we had to do is to actually remind those guys that this is not easy. Because I think they forgot that what they do is actually really, really, really difficult, and they put a lot of work to achieve what they had. So huge, huge bravo for all of you and for the amazing projects that we showed today. Moreover, it's about the students, but also there is a really strong team behind the scenes who are there to support them from the very first day to the very last day. And I just wanted to say thank you to Agnieszka, Gaetan, Killian, Ryan, Tim, Adrian, Brigitta, Bruno, Dani, Eloise, Frederick, Gael, George, Greg, Hi, Jesse, Kai, Marie-Amélie, Nicholas, Paolo, and my partner in crime, Ben. And without Ben, this wouldn't have happened. And I just wanted to say thank you a lot for going through this together, all of us. And that's it for the guys watching. Thank you so much. Have a great night. And for you, please stay with us for a second on this floor because we had some stuff for you still. Okay? Thank you.